So you have a toolbox, right? You already have some stuff in your toolbox. Shall we add more things to your toolbox?
No.
Sir, no? Yes. Away with you then. And enjoy taking the midterm and final. Okay? Because it's all about the toolbox. Alright. So let's talk about how you actually go about doing programming. Whether or not you know Python or not doesn't really much matter. But so let's back off for just a brief moment. Because when I look into your eyes, I see that sort of eager programming fever. And it's like, hey, wait, there's a homework problem, there's a test problem, there's an assignment. I'll whip out my laptop and just start cranking out some code, which right now is pretty much print statements, but still. Okay, and the question is, well, is that the right way? Is that how real programmers do it? You just start like cranking code? The answer is no. It is tempting to do that. I'm 100% on board with you there. But the answer is no. When you bump into something that's going to require some software to be developed, it's in your own best interest to slow down just a moment. Okay? What you want to do is take a look at the problem. And you want to make sure that you fully understand the problem that you're going to be implementing. Okay? What you really want to do is you want to try and solve it by hand. You know, you may think you know how to solve the problem, but you could also be completely wrong. And you could produce beautiful code that solves it incorrectly, which means you now have trash. Congratulations. And it took you X how long to do that trash? Because it's only going to take you longer to program it than do it by hand, right? Yeah. All right. So if you can't do it by hand, then you can't code it. There's nothing magic about coding. Well, I think I'll work it out as I create the code. No, you will not. All right, so let's talk about what I like to call the flow tile problem as an example. Okay? So, you've been given an assignment. Okay, there's a row of black and white tiles that are going to be placed along the wall. All right, well that sounds pretty simple. Okay? For aesthetic reasons, the architect has said it's going to start with a black tile and it's going to end with a black tile. All right, art is art. I got no problem with that. And then there'll be a little gap on both ends. All right, that's pretty reasonable. Your task is to compute the number of tiles needed and the gap at each end, given the space available and the width of each tile. So your computer program will have two inputs. What are those? What's that? Given, which is pretty much length of wall, right? And tiles. Those seem like the two types of things that you need. And what are you actually going to create? You're going to compute what? Number of tiles needed. So you go to Home Depot, get the right thing, and the gap. So you're going to have two inputs and two outputs. Make sense? I mean, this is not rocket science. Okay? We're not launching these into space. Okay, that's a pretty generic problem. I personally struggle to wrap my head around generic problems. It's like, so X and then Y, and so screw it. Let's play a game. Bam! Your wall is 100 inches long. Okay? Your tiles are 5 inches long. We're making it up. But whatever you do should work for this, right? It should also work for your wall if it's like 500 inches long, right? And if your tiles are like 2 inches long, right? It should work no matter what, okay? So, but it should certainly work for this. So I've got 100 inches, which is how long my wall is, and each one of my tiles is 5 inches. Are you on board? This is not rocket science. All right, we're laying tile. Okay, get comfortable. There's going to be a lot of dust. You're going to get stuff on your hands, and you know your back's going to hurt when you're done with this. But so what? It's going to look really nice when you get done with it. All right. So let's see how we're going to do this. We're going to solve the tile problem. Well, it doesn't seem like it's that hard. How long is the wall? How wide is the tile? Okay, do some math here. 100 divided by 5 is 20 tiles. And bam! You got your answer. Wow, that was tough. What problem? What's that? Let's play a game. You're right, but in this case there wouldn't be one, right? Because we perfectly fit out the space, right? Ha-ha! But there's one other problem. It was so good up until you spoiled it and brought up that point. So this is not actually an accurate solution, is it? No. Our only requirement is it starts with what? And ends with what? And there's supposed to be a little gap at the closing, right? I mean, I can put down 3 damn tiles and say I'm done, right? And my gap is like 8 feet. Then the answer is no, that's not really what we're going for. So obviously, they didn't say it, but let's say your goal is to minimize the gap. Okay, gap is okay, but minimize the gap. Okay. All right, so this was a great solution, but it was wrong. So let's see if we can come up with something else. So how wide is the tile? Okay, so we know we're going to start with a black tile, right? You can come up with a zillion solutions, but it will always start with a black tile, right? Then after the black tile, we know that we're going to have a white tile and a black tile, right? Guaranteed, 100%. How wide is a white tile and a black tile? 10, right? All right. So now we have sort of like this unit thing, right? So we can add more of these, right? And we're still cool. I mean, if we stopped right here, we would have met the architecture requirements. Start with the black, end with the black, right? So what we really, and we're also dealing with what, 95 inches, right? So maybe if we can figure out how many of these pairs we can fit in there, we have a good answer, right? Once again, not rocket science, but it seems like we're getting a little bit closer, right? Because if we're doing this pair stuff, then we guarantee we're going to end up with a on the end, right? Okay, this sounds pretty good. So now we do a little bit of math. We say 95 inches, which is what we have left, divided by the 10-inch 2-tile size, comes up with what? 9.5. Throw away the 5, and we have how many? 9 sets of 2 tiles, which is how many? A total of 18, right? So we sort of have an answer here. But of course, no, it's not really 18. It's really 1 black tile, forgot about that, plus 9 sets of 2, which is 18, gives us a total of? It's odd, because I heard sort of like different answers. Okay, the answer is 19. Okay, 1 plus 18 is 19. Okay, excellent. Now, how big is our side gap? So we have 100 inches, we have 19 times 5, 100 minus 95 gives us 5 inches. 5 inches divided by 2 is 2.5 on both sides, right? So our program had 2 inputs. In this particular case, the size of the wall was 100 inches. The size of the tile was 5 inches. We were required to produce 2 outputs. Number 1 was how many tiles. How many tiles do we need? 19. And we're supposed to figure out how big the gap is on each side. How big is the gap on each side? 2.5. Great. So we've done this, right? We did it by hand, but we're there. So it seems like it wouldn't be a lot hard to come up with a program. Well, that's cool, but what we really need is, big word, an algorithm, right? An algorithm just means we need a way to do this for any size wall and any size tile. That's no big deal. I mean, in the world of Python, we're probably talking about variables and stuff like that, but we're not even going to worry about that right now. Number of pairs of tiles, it's going to be the integer part. Remember, because we came up with what, 9.5, right? Throw away that 0.5. Hey, in Python, how do you throw that away? What was the command that we used to throw away the fractional part of a decimal number? No, float turns an integer into a decimal number. So that's good. All right, you're in the right neighborhood. You're just at the wrong house. Int, exactly. So int will just basically take a chainsaw to the decimal point, right? And just throw it all away. It actually gives you an integer. And you're done, right? Cool. All right, so integer part of total width, so how big the wall is, minus 1 tile worth. Because we know we're going to have a tile, right? Okay, so that's like 95 in this particular case, divided by 2 times 1 tile, right? That's exactly what we just did. Okay, number of tiles is 1 plus 2 times the number of pairs. Right? That was 9 in our case, so that came out to 18 plus 1 is 19. And the gap at each end was the total width minus number of tiles times tile width divided by 2. Fancy, oh well, that's all complicated. No, it's not. We just did it. We just worked it out. That's my algorithm. This, I could turn into a computer program. This would be pretty straightforward, right? Give me 2 inputs, and run it through this, now I get 2 outputs, life is grand, right? And because I worked it out by hand, I know this is right, right? I mean, I can still screw it up, I might code it wrong, but at least I mean, look, if I turn this into a program, I could give it 100, and I could give it 5, and I know what the answer should be, right? 19 and 2.5, right? Crank that out, I'm good to go. Got it? We can now solve this problem for any width of a wall and any width of a tile. Fantastic. We are ready to go into the tile laying business. This computer stuff is the coolest thing in the world, I tell you. All right. Steps necessary to finding the solution to the problem. All right. Math problem, here we go. So you put $10,000 into a bank account that earns 5% interest per year. How many years is it going to take for that account to double? So this is actually not that hard of a problem, but man, this is just exactly the kind of problem they created computers for. So let's talk about what we got here. So this is your bank account. This will be the interest that you earn. So you're going to put $10,000 in your bank account, right? The very first, end of the first year, how much interest will you have made? Without that cell phone, $500. Excellent. So you will have made $500. Through the magic of compound interest in your bank account, how much money will you now have? Excellent. That is fantastic. So year number 2, how much interest will you make on $10,500? $525? So close. 525, so we come over here, and we got what? 1125, right? And you see how this goes, right? That's not that hard to do, but you worked it out by hand, so you can sort of see how this thing's supposed to work out. So we can get all fancy and come up with stuff, but basically, by working it out by hand, we know what we should be looking for, right? Now it's actually pretty easy to code this up. Right? It wouldn't be that hard to do. Give me a couple variables and I'm off to run it. Woo, right? So I've got an algorithm to solve this problem. I did it by hand, I'm comfortable with the solution. Now, I can start to write my computer code. Right? You will meet lots of people who jump in and just start writing out code, which is great. It's a lot of fun, but oftentimes what's going to happen is they're going to reach the end, they will have the wrong answer, and guess what they have to do then? And it gets even worse, because they can't even really sort of reset and start all over. What happens is they go back and they take a look at the code that they wrote and they try to figure out what they did wrong, which takes even longer to fix something that you've already created, right? Okay, so it's all in the description. Create a description of the steps for finding the solution. Each step must be clear and unambiguous, requiring no guesswork. Lay out your algorithm. Lay out what you have to do. Write it in English. We're not programming it, right? Do this. Place money in checking account. Calculate interest. Add interest to money in checking account. Recalculate interest. It's really pretty simple stuff, right? We call this pseudocode. Pseudocode is English stuff that you scribble on a piece of paper that if you take a look at, describes the steps that you have to do. Oftentimes we will write our computer software based on our pseudocode, right? And pseudocodes are just instructions to you. It has nothing to do with Python, and everything to do with the steps that you'll go through to solve the problem, okay? Because it's just you have a problem, you think about it, you write out your pseudocode, you have your pseudocode in front of you, that's what you use to write your program. Got it? You'll hear pseudocode talked about in a zillion years. People will give you their pseudocode and say, hey, code this up. Da, 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 da. You probably can't read their pseudocode because it's just scribbles on a piece of paper or whatever. Okay, what's an algorithm? Hey, so understand the problem, develop and describe an algorithm, test the algorithm with sample inputs. Hey, nice algorithm. Is it right? Don't know. Let's give it a sample input. Okay? Translate the algorithm into Python and compile and test your program. Because remember, translate the algorithm into Python, you may not do that correctly. So you got to test it, make sure that it works. Remember, this is where you go back to test it with simple inputs. Algorithm is a sequence of steps that's unambiguous, executable, and terminates. If it runs forever, you're screwed because you're not going to finish it, right? You have to know the algorithm before you can actually program it. Okay? You need to first discover and describe the algorithm so that you know what you want to do before you program it. Okay? So this is just saying, hey man, when you get a programming assignment, stop. Whip out a pencil, whip out a piece of paper. Make sure you know how to solve it before you start typing on that keyboard. Make sense? Say hello to strings. So now we're in Python. Ready for this? All right. So your computer programs will deal with lots and lots of numbers. But that's not what we're going to talk about. Your computer programs will also deal with characters. Sometimes it's going to be a single character, and sometimes it's going to be a bunch of characters stuck together, perhaps in like a word, or a sentence, or a paragraph, or a complete book. Don't even care. When you stick characters together, or really when you have characters in any shape, we call that a string. Why do we call it a string? I've got no freaking clue. probably back in the 1960s, somebody saw a bunch of characters stuck together and said, wow, that's like a string. Whatever, who knows. But anyway, we call them strings, okay? Text consists of letters, numbers, punctuation, spaces, and pretty much anything else you can get into the computer via your keyboard or some other method. Little emoticons, that'd be fine. That'd be part of it, right? A string is a sequence of characters. John Smith, notice between quotes, right? John Smith is a string. It's not a number. It's not an integer. It's not a floating point number. It's a string. Exactly, right. How do we deal with strings? Well, you can have a variable equals, quote, quote, pow. We're good to go. We store them in variables. Sounds like a good place to stick them, right? A string literal, which is just a phrase, is just a particular string. Okay. You'll hear string literals here, but it's generally something fixed. January, February, March, April, May, June, those are string literals. I'll load them up into a program and I'll use them later on, right? Okay. In Python, string literals are specified by enclosing a sequence of characters within a matching pair of either single quotes or double quotes. Python doesn't care. Use whatever one you want to use. But if you put a double quote, you better end it with a. If you begin with a single quote, you better end with a. There is no such thing, I don't think, as a triple quote, but yes, okay. So you choose what you want to use. Traditionally, we use double quotes. I'm just saying, if you go to other languages, you're going to see double quotes. Python's holding your hand here. Python says, I don't care, use whatever you want. Okay, I'm cool with it, not a problem. Just be consistent. Okay. Concatenation and repetition, and you will do a lot of this in your life. Okay, concatenation is when I have a string here, group of characters, and I have a string here, group of characters, and I want to stick them together. Fire truck, put it together. Fire truck. Okay. Vacation equals under quote quote plus water quote quote, and guess what it creates? Underwater. There you go. So you can actually add strings together. All you're doing is sticking them together, right? And either you're printing it at that point in time or else you're sticking it in another variable. Okay? If you want to put a space into that, I've got Christmas in quotes plus quotes around one space plus quote tree unquote gives me Christmas tree. Got it? So the concept of addition does mean something when you're talking about strings. But notice what I'm not doing there. I'm not adding any numbers to a string. What would Christmas plus 100 be? I don't know. Do you enjoy seeing Python error messages spewed across your screen? If so, go ahead and do that, right? Because Python's going to go, I've got no clue what you're doing, right? I can add strings to strings, and all it does is stick them together. I cannot add numbers to strings because Python's got no clue what's going on there. Here's something sort of cool. Repetition. It's weird, it's strange. Dear God in heaven, you'll probably never use it, but you should know about it. I can say dashes equals, quote, dash times 25. If I do that, I'm going to get a string that's how long? 25. And what's going to be in that? Dashes. Dashes. I could also have dashes equals Mississippi times 25. And what would I get? Mississippi, Mississippi. Right. Now, you guys just did an assignment where you created a happy face, right? Would this maybe have been helpful to have? You could have used it. I mean, I'm not sure how, but possibly you could have. You wouldn't have had to do a lot of typing, right? You just that, and you would have been good. If you're doing like a bar graph, though, right? Something with text characters to create a bar graph, would this be helpful? Seems like it would be, right? Because you wouldn't have to space, or do anything like that. You could just go times whatever, and you go out. All right. Converting between numbers and strings, and you do this occasionally. You don't do it necessarily every day, but it is something that does happen. So, if I want to convert a number to a string, why would I do that? Because I want to stick that number into like a phrase or into a string someplace. The year is 2015, and it's been a good year so far. I'd like to create a program that allows me to put whatever year it is into that string. Well, what I do is take 2015, turn it into a string, and stick it in there, okay? So here's what we do. There's a function called str, string, and we pass it a number, in this case 17, and what it produces is a string that contains the characters 1 and 7. doesn't produce 17 in a string. It produces a string that has 2 characters, a 1 followed by a 7. What it means is this string you can no longer add to, you can no longer do integer on it, you can't turn it into a floating number, because it's a string, right? So you can convert any number into a string. Very easy to do. Maximum fall rate equals string 9.8 plus meters per second produces 9.8 meters per second as a string. Got it? All right. Now let's see if we can do it the other way. Convert a string into a number. Huh? Really? Yes. So if you want to make it an integer, okay, int paren 17 produces 17. That int thing's pretty common. Same thing with float. Float, pass in a string, 17.0, and you get 17.0 popping out the other side. For example, if I had a database and I read in a house number, and it came in as a string, I could do integer on the house number, and then poof, I'd have a real actual number. And I could sort or add or figure out how far away other houses are. I could do stuff with it like it was a number, because it would be a number. Understood? All right. So if you have something a string, you can turn. If you have a number that's a string, if you have a number, you can turn it into a string. If you have a number that is a string, you can turn it into an actual real number and go off and do math on it all you want. Okay? So you can flip and choose and go between these things left and right. Strings and characters. Ooh, this is sort of important. All right. Strings are really sequences of what we like to call Unicode characters. Remember when we talked about the ASCII system? Okay, ASCII is like old school. Okay? Unicode is new school. It's really ASCII on steroids. Unicode is just bigger than the ASCII system. I think Unicode has ASCII in it, but it also has more stuff in it. Okay? So basically, strings are sequences of basically numbers. Remember how we had capital A was really the number 65? That's what we're talking about here. So you can access the individual characters of a string based on their position in the string. Okay, this gets interesting. So here I have the word, or whatever it is, tiles. Okay, the first location, and this will trip you up every single time. First location is what? 0. Python starts counting from 0, not 1, but 0. Okay? Next is 1, 2, 3, 4, and the last one is position number 4. So each one of the characters in the string that contains tiles has an individual location, and I can reference that individual location. I can talk about the string, or I can talk about each individual character in it. That seems like that might be sort of powerful to do something, right? So let's see. So the variable name contains the string tiles. Yes, excellent. That sounds good. Length of the variable name comes out to be what? How long is it? How many characters? 5 characters, right? That seems like that'd be handy to have. And if I say name, square bracket, 0, square bracket, and 0 is what? The first character. Comes out to be what? Right? And if I do name, square bracket, 4, square bracket, I get what? So I can pick out every single character in there if I wanted to, right? I could have a little print statement that said, print name 0, print name 1, print name 2, 3, 4, 5, and I can basically print tiles, right? Sort of stupid, but I could do it, right? All right. Seems like it might be handy to do for some reason. String methods. Okay. This is just little things that are worked into Python, little handy things if you needed them. A method is just like a function call. It's a collection of programming instructions built into Python that carry out a particular task. String name dot lower turns an entire string to lowercase. String name dot upper, guess what? Makes everything upper. Why would you want that? Well, if you're sorting strings alphabetically, you'd really like them to all be upper, all be lower. Because remember, capital A is not the same as lowercase a. So you're going to get different values, even if it's spelled exactly the same, if it has capitals or lowercase a. Here's an interesting one. String name dot replace old string, new string. So if I had John Smith and I did replace John with Mike, what would I get after I ran that? Mike Smith. All right, so that means I can change anything in a string that I want, right? Sound powerful. Okay, all characters have number. We already talked about this, but let's revisit it for just a second here. Character stored internally as an integer value. Remember, a CPU computer, it doesn't know anything about characters, right? It only really deals with binary numbers. It only deals with numbers. So it has no clue what a capital A is, what a lowercase a is. Specific values are based on the ASCII code or really Unicode. Python provides two functions related to character encodings. OR, if I send it a character, OR, it's going to give me a number. It's going to give me basically the ASCII number for that. Remember, A is 65. The flip side of that is character, CHR. If I pass character a number, in this case 65, it's going to give me a capital A. I use this every once in a while, basically to convert between numbers and characters. What the cool kids know. All right, if you want to be cool, this is the kind of stuff you got to know. Okay? So here's the scoop. If I had a string and I wanted to put a double quote inside the string, I run into a problem, right? What's going to happen when I put that double quote in there? What's Python going to go? End the string, right? And then I'm sort of screwed, right? So what they have is what's called an escape character, okay? Escape character is simply a backslash before the double quote. And what the backslash says is, hey Python, one moment please. I'm not really ending my string. I just want to put this character in the middle of my string. And Python goes, oh, that's part of the string, not the end of it. Not a problem. And it keeps going. I have another one here. Oh, that's not the end of the string. I'll just stick it in the string, and then I end it all with a double quote. Oh, you really need to end the string here. Yeah. Okay? Escape sequence. Now, what's interesting is, well, I want to put a backslash in my string. Backslash, backslash. Problem solved. It's yet another escape sequence. Sometimes you'll also see escape sequences with numbers after it. If you have that, then what you basically do is you're using the ASCII value of a number and putting it into a string, right? So if I had backslash 007, it might be like the bell sound or something along those lines. Another common escape sequence, for example, here is backslash n. Backslash n means go to the next line. So if I'm printing something out, print, double quote, star, backslash n, star, star, backslash n. What I'm going to get is star on the line. Oh, backslash n. Oh, I should go to the start of the next line. Oh, 2 stars? Oh, wait, another backslash n? Oh, I should go to another line. So, you know, if you don't want to have a bunch of print statements, you can put it all in one print statement. You just have to put a backslash n when you want to go to the next line. It gives you a little bit more control over your output. You make things look pretty. Input and output. Sounds like a good thing to do, right? You wouldn't want your computer just to go run it off and assume that it knew what was going on. Like our tile problem, right? How many inputs do we have to give to our tile problem? 2, right? We had to tell it what? We had to tell it all along the wall was, and what else? How wide the tile was, right? The way to get it in there. The way you do that in Python is you use what's called the input statement. And you can just have input, paren, and be done with it. But what that means, you know what the user is going to see on the screen? The question mark. And whenever you see a question mark, you do what? Note. I've got no clue. So, the way Python's set up is it's input, quote, something that's like a prompt. Enter your password, enter your social security number, enter the size of the wall, enter the size of the tile, double quote, ends it, and what you'll see is whatever you put in there in the text, and then it'll stop. And it'll ask for input. Okay? It's really simple. That's the input statement right there. Okay? Displays the string argument in the console window and places the cursor on the same line, waiting for you to share your knowledge with your Python program. Okay, here's something sort of weird about Python. Now remember, in Python you get to use variables whenever you want to. You've not told Python whether or not the variable that you're using is a number or a character. You haven't told it if it's an integer or a float. You haven't told it anything about it. So when Python goes out and grabs some input, it's got no clue what it's getting. So it assumes that everything that it grabs from the user is a string. So if we asked in our problem, hey, I'd like to have the user enter the size of the wall and the size of the tile, what's the user actually going to enter? Two numbers, right? 2 integers. And what are we actually going to get? We're going to get two strings, right? In one case, it's going to be a string of 1, 0, 0, and the second string is going to be the digit 5. But they're not going to be numbers. They're not going to be useful to us, right? We've got a little bit of a problem. What we need to do then is we have to convert them. You already know how to do this. So this example here is number of bottles. Input, please enter the number of bottles. And so that goes into number of bottles as a string. So what we now need to do here is bottles equals integer number of bottles. So we're taking that string and converting it to an actual number, then we can run off and do stuff. Now if we're going to get something that has a decimal point in it, we say bottle price equals input, enter the price of a bottle, $2.75, 75 cents, who knows what it is. We say price equals float, bottle price. Make sense? So remember, and this is important, because you'll forget it. You'll be like, wow, my program's not working. I wonder why. Everything that you input into a Python program comes in as a string. And if you want it to be something else, you're going to have to actually convert it. Shall we write a sample Python program? Now we're going to use the fantastic string knowledge that's stuck in your head, okay? It's a simple program. It can't be that hard to do. So I want you to write a program that reads a number between 1,000 and 999,999 from the user, where the user enters a comma in the input, then print the number without a comma. Okay, here's a sample dialog. Please enter an integer between 10,000 and, 99999. User entered 23,456. Program outputted 23456. Now what's interesting about this is that there's actually two different ways to solve this problem. I went ahead and solved it one way, and I went, oh, I don't think that's actually the right way. I went back and had to solve it the other way. So let's see what we can do here. Using our fantastic new Python skills. Okay, so input. Is that our input statement? Oh, hey, look at that. All right, well, we've got that. Here, let's try this. That'd be 2, 3, 4, 5, 7, right? Damn it. Well, that's no good. Well, how about this? That should do it, right? What did I do wrong there? Well, that didn't work out so well. And why did that not work out so well?
Comma throwing off?
Aha! You're exactly correct. So 2, 3, comma, 4, 5, 6. It says I can't turn that into an integer. What the hell is a comma doing there, right? All right. So we've got a problem. We've got a string and it contains 2, 3, comma, 4, 5, 6, and we want to get rid of the comma. Your brain is now full of string manipulation commands. What would you recommend as a great way of going about doing this? Can't be that hard. It can't be that many different ways to do it, because I haven't given you a zillion different ways to do it. You want to get rid of the comma.
Can you use that?
Like when you said you didn't want to use that spot in the third spot, would that be, the comma would always be in the third spot, wouldn't it? So,
Well, you know, you bring up an interesting point, and actually it's a fair and valid point. Let's go back and take a look at the statement of the problem, shall we? You know, it's interesting the way they phrase the problem, because our input has to be between what? And so we're guaranteed there's going to be at least how many digits? Right. So is the comma always going to be in the same spot? I think it is, right? So for what, because we can't have 999, right? We can't have anything less than 1,000, right? So we know exactly what's going on. All right, so we always know that the comma's going to be in the same spot. That's good. I'm sorry, what's that?
And you have like all 6 numbers, like you got 800,000 compared to 8,000.
Comma's always going to be in the same spot. Because it's going to be there for 1,000, right? And all my other numbers are going to be greater than 1,000, correct? And the comma's not going to move for those, right?
From the other side.
Well, now you're playing game. Oh, good point. Good point. From the right, well, you may bring up an interesting point. One thing that we have done is, how long is the string? We got that length thing, right? How many characters are there in the string? 6. So from the right side, we know it goes to what, like 4th character, right? Now, admittedly, 999, 999 is going to be how long? How many characters in that string? 7. Right, which is greater than what we currently have, which is 6, right? All right, so we have to be a little bit careful about this, but if we started our counting from the far right, it's always going to be in the same spot, right? Right.
So what should we do here, guys?
We want to get rid of the comma.
Would it change anything if we got rid of it?
What's that?
Would it change anything if we got rid of it?
Well, yeah, well, first off, we can turn it into an integer, right? Because we tried to do that whole, hey, it's an integer, and it says, oh, sorry, I can't do it because you got a comma. So I would argue we want to turn it into an integer. We don't want to do that if we get rid of the comma. Got a problem, right?
Like put the stuff before the comma as one thing, stuff after.
Great, then I got 2 numbers.
Yeah, put it together. Then you got one
Could do
number.
that. Well, how am I going to do that? I mean, the concept sounds pretty good. How?
I don't know. I come up with it.
You're not really looking at the right thing from the left, you count the size, and then you count the size, and you go under the command, and then omit whatever space that would be, or move the comma.
So if it had 7, do it with this spot, was it 6, do it with this spot?
Yeah, and what's my goal here? What the actual problem
Yeah,
is.
those by allocator would work.
Print the number without a comma. So we don't actually really have to turn it into a number to do any sort of additions or anything like that. We just have to be able to print it without a comma, right? So what were we talking about here? There's something that sounded sort of interesting. What was it?
You have to have it, whenever you input something, you count the length of the string.
Okay, bam, we got that.
And then if it.
By the way, what is our length?
6.
Okay, gotcha.
So like in this instance, it's like the comma's in the 3rd or the 2nd position, so 0, 1, 2, so 2.
Okay.
So you have to like, depending on whatever length you put in, you give it a good value for check for this spot, and then you'll get that.
So skip that spot. So what I think you're saying, and please correct me if I'm wrong on this, is I can come up with a print statement. It would look like this. Like, so print value of. And what's the first index that I'm going to be dealing with? What number? What will the 2 be at? Which is what? What number do I use? Gotcha.
No, oh, I
Gotcha.
thought you meant like,
No, don't come up with some weak excuse.
whatever.
What index would that be? Okay, so we're saying 0. Now, we know we can put strings together, right, by using plus, right?
Yeah.
So I guess I should do 1 next, right? So I got the first 2 characters. Now what should I do?
Skip the second one.
Whoa. So you guys are saying skip 2? do you think? Is that gonna do it? Let's find out. Congratulations, looks like that did it. What a pain in the duties. Now, there's another way to do
Is
this.
there like an omit?
What's that?
Is there an omit option? Omit this side?
Just, hey, just don't print this part. No, there isn't. I'm not even sure how you talk about that. Just skip this part. Yeah, doesn't work that way. But you do bring up an interesting point. What do we really want to do with the comma? We want to do what with it? Basically, remove it.
Yeah.
Okay, another way to think about remove would be maybe to, another R word would be replace it with what? With nothing. So if we could replace the comma with nothing, we'd be there, right? Now, did we talk about a replace statement? Right, it was one of those method things, right? A string name, dot, replace, and then a bunch of stuff. So let's give that a shot. So, we'll double check, is value still what we think it is? It is, it still has a comma there. So print, value, replace, what are we going to be replacing? Comma, right? With nothing, right? So I just put two quotes together, which is basically nothing. Alright, so this is print the string value, and we're going to apply the method replace to it. And we're saying replace the comma with nothing. And so what are we expecting to get out of this? The number without a comma. Let's give it a shot. Hot diggity! Look at that! How cool is that? So effectively, two ways to do the same thing, right? Now, we've talked about this before. So when it comes time to write some code to solve a problem, is the way you write it going to be the same way I write it? No, absolutely not, right? The beauty of software is basically you can think of it as a bunch of like oil paints, and you're being told to paint a landscape scheme. Okay? You'll go ahead and paint that scene the way you see it. I'll paint it the way I see it. We're using exactly the same paints, exactly the same canvas, and exactly the same brushes, but our picture's going to look different. Same thing with code. Okay? You're just painting a picture with your software. The one picture that you paint will potentially be greatly different from mine. Hey, there may be parts of it that are very similar. In fact, even all of our code may be similar, but it's entirely possible we might solve it in a completely different way. Okay. Here's something that's sort of interesting. It's actually sort of valuable. So in Python, it gives you the ability to closely format your output. What does that actually mean? Well, if I say print a number, it's going to print a number, right? But what if I wanted that number to be right justified on the right-hand side of the line? Well, I guess I could put a bunch of spaces in there, right? But what if the number's a really big number? Oh God. Now you have to figure out how big the number is, so I can figure out how many spaces to put in there to make sure that it's going to be right justified. See how this gets crazy very quickly, right? Python says, hey, don't worry about it, man. I'll take care of it. Okay? Here's how it does it. You do a print statement, double quote, and in that print statement, you put special codes. Okay? Special codes are indicated by percent. Percent, and then a number says that percent D says I'm going to put an integer there. Okay? Total equals percent 10.2f. What? Okay, 10 means the window for printing this number is going to be 10 characters long. 0.2 means when you print this number, I want there to be 2 positions for the decimal point. Sort of like currency. 0.75, 0.61, whatever. And then the F means it's going to be a floating point number. Okay? So D basically means integer. F is floating point. Got it? Okay? And then, after you do this quote stuff, this is sort of new. You put a percent sign, and then you put parentheses, and then the 2 values, parentheses, that you want to have printed. So it's a little bit weird. It's It's a little bit different, but you've seen all this stuff sort of before, right? So one more time. It's a print statement, which you're very familiar with. Double quote, double quote. This is what you're actually printing. Inside you have secret messages to Python. %d means I would like to print an integer there. %f means it's going to be a floating point number. 10.2 means it's going to be this wide, 10 characters wide, and 2 of those characters are going to be used for the decimal point. What's interesting is one of the other characters is going to be used for the actual literal decimal point. So the total number of characters you have left to work with here, 7, right? I've used 3 of them. 3 of them for the numbers that come after the decimal point, 1 for the actual decimal point itself, and then I've got 7 characters for the main, basically integer portion of the number. Okay? Plugged in, it's called a string format operator, which is all that all this sort of stuff is, and we talked about exactly what that meant. If I want to specify left justification for a string, I can actually put a minus before it. So it'll pull it all the way over, right? So title 1 is quantity, title 2 is price, print, double quote, remember the percent thing, minus 10. What it means is in my window of 10 spaces that I'm going to print this number, left justify it. Okay, so in that window of 10 characters, shove it all the way over to the left because I put this little minus sign there. Okay? So I'm going to do title 1, comma 24. And here we do quantity is 24. And quantity is shoved all the way over to the left. If I hadn't done that, quantity would be all the way over to the right. Okay? I do the same thing down here. Print dash 10s. S means I'm printing a string. So we had D meant integer, F meant a floating point number, and the last one that we have to remember is S, which just means string. Okay? Do that, price is shoved all the way over to the left, and then 17.29, 10.2, side of that, you're good to go. Make sense? Just gives you the ability to produce beautiful looking output. You're in complete control of your output. Here's everything you ever needed to know about format specifier. %d, just an integer. I'm just going to print a number. %5d means that there's 5 spaces. I'm going to print the integer and it's going to be stuck off to the right. So if the number isn't big enough to fill the space, I'm going to have 9 spaces. %05d, I'm going to print a number in a window that's 5 characters long. And any place that I don't actually have a digit to put, it's automatically going to put a 0. If you're printing odometers, you might do something like that, right? Quantity, E:, %5d, so you print the string quantity, 5 characters for the number, and that's right justified. %f is a floating point number, which means, of course, it has a decimal point in it, right? We talked about that last one. %.2f just simply means that there's only going to be 2 digits after the decimal point. 7.2 means the total size is 7 with 2 digits afterwards. %s is a string. We know about strings, right? And then you can do a bunch of other stuff. We won't go into all of them, but you get the gist of it. You have full control over what the output that you print looks like. All right, let's talk about what's in your Python toolbox. You've got the print statement, your old friend, right? We've already talked about math. Now we've talked about strings, and we've talked about I/O. Starting to get sort of full up in there, right? Starting to get almost enough stuff for you guys to get a homework. But that's for next week. All right, what did we cover today? We talked about algorithms. We talked about strings. We talked about how getting input and output into the program works. Next time around, we're going to be talking about our best friend, Mr. If statement. And we'll talk about relational operators also.